All right, so here we go. All right. So, like I said, guys, proving two triangles are congruent is really, really important in geometry. And you just have to be patient with me. You'll see it as we move through our geometry studies. At first, it's not going to seem like a big deal, and you're not going to be all that excited that two triangles are congruent. But we move through our as we move through geometry, you're going to see that congruent triangles are such an important thing. So, first of all, let's talk. We have two questions here. So I want you guys to write this down. What makes TWO here? Sorry about that. Let's put TWO there. All right. What makes two triangles congruent? And the next question is, what is a triangle congruent statement? Now, a couple other things I want to show you in here while you're writing this down. Normally, I'm not going to write the word triangle. I'm just going to use this as the basic symbol for triangle, right? So you don't have to write this down, but this is the symbol we're going to use for all triangles. Doesn't matter if it's a right triangle, obtuse triangle, acute triangle, equilateral triangle. It doesn't matter. This is just the symbol for triangle that we're going to use in here. You guys all good at that? So what's going to happen is I'm going to quit writing the word triangle a lot, and I'm just going to use that symbol instead. Okay, and then I think we've talked about this. This is the symbol for congruence, right? Okay, so in geometry, we're highly symbolic. Okay, you guys with me on that? Okay, so as you can see, what I have here, ladies and gentlemen, is I have two triangles that are all marked up. Okay, now remember, what do those slashes mean, guys, on the side? What do the slashes mean? Like I have one slash on this triangle. Notice I have one slash over here. What does it mean to each have one slash on their side? That means they're congruent, right? You guys see that? And likewise with the arcs, the angle and the arcs. Now, there's different ways that different people symbolically do it, but this is a pretty standard way of doing this. Okay, so what we're going to do is when we're going to make two triangles congruent, what makes two triangles congruent? Well, the answer to that is all corresponding parts must be congruent. Okay? So in order for a triangle to be congruent, two triangles to be congruent, all their corresponding parts have to be congruent. You guys with me on that? Okay. So let's say, ladies and gentlemen, let's look at this. So when we say parts on a triangle, triangles have two kinds of parts. They have sides and they have angles. Y'all with me on that? They have sides and they have angles. Okay? Now, if we look at side AB, if we're looking at the picture, what side is congruent to side AB, guys? DF. So we can see because the picture is telling us AB is congruent to DF. And we know that because the picture is telling us that. There's two ways to see it. Either they can give us an actual measure of the sides with a number, or they can do a congruent slash an arc for the angles. You guys see that? So someone give me another pair of congruent sides. Will?
AC and DE.
We all agree that AC is congruent to DE. Y'all agree with that? Okay. Anyone see another pair of congruent sides and angles? Or side? Let's stick with sides. Tanner. Okay. B, C, and F, E. Okay. Y'all agree with that? So we can't have any more sides because the triangle obviously only has three sides. Now let's look at angles here. So give me two angles that are congruent based upon the given markings here. Give me a pair of angles that are congruent. Sam?
Angle A and angle B.
Yes, angle A is congruent to angle D. Now, Sam, why do we know that angle A and angle D are congruent?
Because they have the same amount of arcs.
They have the same amount of arcs. Very good. And what's another one?
Angle B and angle F.
Angle B and angle F. Okay. Y'all agree with angle B and angle F are congruent? And then I'm kind of running out of space here, so I'll put it up here. Someone give me another pair here. What's another pair? Tess, what do you got? C and E. Angle C and angle E. Y'all agree with that? Okay, now, are all of the corresponding sides congruent, ladies and gentlemen? According to this picture right here. Yes. Are all the corresponding angles congruent? Yes. So that's what makes two triangles congruent. So if all corresponding parts are congruent, then the two triangles are congruent. Okay, in other words, if I had a pair of scissors here, I could cut out this triangle and I could slide it on top of that triangle. And that's what we did the other day, right, guys? We cut out two triangles and we slid them around and showed that they're congruent by putting them on top of each other. Okay, now, but sometimes we don't want to slide. Sometimes we just want to use given information and just be able to make that decision. So since they're congruent, what I'm going to do is first of all, I'm going to put a triangle symbol. This is called a triangle congruent statement that I'm doing. I'm going to start with the triangle symbol. Now, I'm going to pick a letter on this triangle. I'm going to start with A. Doesn't matter. We could pick any letter. I'm going to pick A just because alphabetical. And then just to be fun, I'm going to go alphabetical. So this is A, B, C. There's nothing that says I have to go A, B, C. I just chose to. So what did I do? I went from 1 arc to 2 arcs to 3 arcs. Did you guys see that? Now, when I name it over here, I have to name it the same way over here. So what letter am I going to start with first, class, in this triangle over here? D. And then I have to go to what? F. And then I have to go to what? E. Right? See that? So now, ladies and gentlemen, we can see that these two triangles are congruent because all corresponding parts are congruent. And so if all corresponding angles and sides are congruent, then we can make a triangle congruent statement. Does everyone see that? It's a pretty simple concept, right? Are there any questions here? Because we're going to kind of just take it up a little bit. Okay, so here's what I want you to do. I want you to look at these two triangles right here. I'll get rid of my face here. That's in the way. Okay, here's what I want you to do. I want you to list all pairs of congruent parts. That's going to be 3 sides and 3 angles, okay, based upon this given information. And then I want you to list, and then I want you to give me a triangle congruent statement. All right. Now, what's the only challenge about this one, class? What's the only real challenge? It's not really that challenging. I've rotated it. But remember, what we talked about is that little triangle. Is we can rotate, we can flip, we can slide, we can turn. And as long as we can put one on top of the other, they're congruent. You guys got that? All right. So, very simple concept, but we don't want to skip over this concept. We want to be really clear with how we do this. Sound good? Okay, so let's do some sticks. Sound good? All right. Let's get my second period sticks here. All right, so Kaylee, have you ever pulled sticks? Who has not pulled sticks? Who's never pulled sticks? Cody, you never pulled sticks?
Yeah, he's gonna make it.
You
I think everybody has.
Cody, you never pulled sticks?
No.
You're the stick guy today. All right, here we go. All right, Cody, pull me a stick.
Nicole.
All right, Nicole, let's start with the sides, okay? Because remember, when we got to list all the corresponding congruent parts. Let's do the sides, okay? So, Nicole, give me a pair of sides that are congruent.
Angles A, B.
Side, we're doing sides.
Sides A, B, and BF.
Okay, do we all agree that sides A, B is congruent to DF? And why do you know that? Why do you know they're congruent? Why do we know that AB is congruent to DF?
They have the same amount of like mark. Oh wait.
There's no marks here. They have the same what?
Measure.
They have the same measure. In this case, we're not dealing with congruent marks. We're dealing with measures. You guys see that? Okay. All right. Keep going. Keep going. Keep going. Cody. All right, Caitlin. Give me another set of sides. So was it? Say it again, Caitlin. Okay. So let's start. Let's go. Just to be consistent, let's go left triangle to right triangle. That's what we did here, right? Not that you were wrong. Let's just so we can organize a little bit. So start with your left triangle and then compare it to the right triangle. So how would you? A what? AC is congruent to what? ED. And why do we know that AC is congruent to ED? Caitlin? They have the same measure of 1, right? You guys see that? Okay, Cody, pull me a stick. All right, Mr. Chris, what's another side congruent statement?
CB and EF.
Okay, so CB is congruent to EF. Okay. Why is that true, Chris?
Because they have the same measure of the square root of 3.
They have the same measure of the square root of 3. Okay, are we done? Can we make a triangle statement, congruent statement here, class? No, what do we still need to do? We need to list out the congruent angles, right? Y'all see that? Okay, so Cody, pull me a stick. All right, Mr. Wyatt, go ahead.
Angle A is congruent to angle B.
Angle A is congruent to what?
Angle D.
Angle D. Okay. All right, Cody, pull me a stick. All right, Sophia, give me another one.
Angle E is equal to angle C.
Okay. All right, Cody, give me another one. Xavier.
Angle F is congruent to angle B.
Angle F is congruent to what?
Angle B.
Angle B. And why is that true?
Because
They're both 30 degrees. Okay, ladies and gentlemen, now we're ready to write a triangle congruent statement. All right, let's go to Cody. Pull me a stick. This person's going to write a triangle congruent statement. Mr. George, what's the triangle congruent statement here?
Triangle ABC is congruent to triangle DFE.
DF. Do you guys agree with DFE? Isn't it DEF? Shouldn't it be alphabetical? Are you sure? Based on congruency, right? That's a little trick there, right? Seeing if you guys are paying attention. Okay, y'all see that? So it actually does take a little bit of work to show two triangles are congruent. It takes 6 things, right, guys? All right, so here we go. So your job right now is I want you guys to copy these down, and I want you to decide if these triangles are if triangles are congruent. If they are, right, a triangle is a congruent state. All right, so copy these down into your notes, please. Okay, go ahead and do that right now, please.
So they're not congruent.
I said it. That looks good. That looks good. You need some hearing aids. That looks. That's easy. You said they are. Yeah. So. They're not congruent. No.
I think he was saying yes, it is.
Okay, Cody, go ahead and pull me a stick, please. All right, Esme, what do you think? Are those two congruent?
No.
Why not? Well, hold on. Wait a minute. I'm going to argue with you because what I'm noticing is I think, Esme, what I think you did is I think you just forgot to delocate it.
Yeah.
I think you're saying, well, one's upside down. Because they're upside down, you can't. Upside down triangles
Yeah,
can't be
yeah,
congruent.
boy.
That's exactly what Esme's thinking. Because, but Esme, let me just kind of, if we take this and just flip it up, maybe turn it a little bit, then I think the 12.1 will be meet with the 12 point that, right?
Yeah, I think they're congruent.
So what do you think?
No, this is so not.
Why?
Because if you lift ACB, it'd be like 8.5 on the left and 7.9 is on the right. But 8.5 doesn't, it's not the same measure as 8.4. And if you flipped it again, then they would align, but 8.5 isn't the same as 8.4, so it wouldn't be the same.
Okay, you guys understand the 8?
Yeah.
That's all. Now, what if we have this though? What if we just had this? What if we had a triangle like this? Okay. We could say NLQ, and this was 12.1, and this was 7.9, and this was 8.5. Couldn't we say those two are congruent now?
Oh.
Even okay, so yeah, I agree. It's pretty obvious these are not. I was trying to argue with you, but you're like, it's Roden. But what about now? Can we say they're congruent? Based upon our definition, can we say that this triangle is congruent to this triangle?
Yeah.
Can we?
No,
Why, Will?
because angle EF is not congruent with angle CB.
Hold on, angle EF.
Will, we're on a different triangle. The one.
Forget about this, Will.
Oh, okay, never mind.
Now we say these two are congruent.
Yes.
What makes two triangles congruent, ladies and gentlemen?
That angle, all the parts are congruent.
Okay, so here's the deal. We got sides, right, that are congruent. Do we have any information about the angles? So based upon our definition right now at this point in time, that we can't make that decision whether they are or whether they're not. You guys understand that? So right now, these two are clearly not congruent. Clearly. And Esme made that very clear. You guys understand that?
Yeah, sure.
These two may or may not be congruent, but we don't have enough information yet. You guys see that? See the difference here? These two are clearly not congruent. These two, maybe they are and maybe they're not. Chris?
But how would they even have different angles?
What?
How would they have different angles if they're the same?
So you're saying that they would have to have the same angles if the sides are the same?
It's impossible not to,
Why would it be impossible, Chris?
because you can't like make an angle different with the same.
Okay,
measure.
now guys, listen to what Chris is doing here. Why is it impossible, Chris?
Because you can't change the angle with the same measures.
What do you mean? So this angle C, why would angle C and angle N have to be the same?
Because their sides are the same.
So we're not talking sides, Chris. We're talking about angles.
Well,
Yeah, but like if you,
but the sides make the angles into the same, so it
because
has to
if you
be
change
straight.
it, then
So what do you-
one side might be a little longer.
What? So you're saying that if the sides are all the same, the angles have to be the same also?
Yeah.
As long as the triangle touches at the.
Well, it's a triangle, right? Yeah, it's going to be a triangle, right?
I would think, yeah.
They have to be the
So that's something to think about, right?
They have to be the same.
Well, why?
Because if you change it, then one side might be longer or shorter.
Okay, you guys are getting at something here. See that? So this is where we're going with this. Right now, in our geometry experience, we can't make a decision, but you guys are onto something here that really maybe we could actually, right? Maybe we don't need all 6 things right now.
We don't.
Maybe there's a possibility of only needing maybe 3 things. You guys see that? Okay, so but that's tomorrow's lesson, okay? So here's the thing. But before we do that, I want to unfreeze this just to make sure you guys understand this concept. So let me erase that board right there. Okay, guys, go ahead and figure out what must the value of x be for these 2 triangles to be congruent based upon our definition of congruence. Okay, so copy these down. Now, we always want to connect that algebra to our geometry. You done that? Okay.
Yes, right here.
Oh, yeah.
And then here's your tool. And if your C compass isn't good, get a better one, okay? All right, thanks, Cody.
All right, not Cody, Brady. Sorry,
Yeah,
you called Cody Brady. I'm sorry,
Cody,
but I can fix that.
Stop making sticks.
All right. So, how would we figure this out? So, before we do this, ladies and gentlemen, what do we have to do here? There's a lot of good stuff here. How would we prove? How would we have? We're going to eventually have to write an equation here, right, class? So, well, we got this p is 5x plus 30, right?
Yeah.
What is it going to have to correspond with on this other triangle?
L.
It's going to correspond with L, but we don't know what L is, right? So before we can figure out, does everyone understand that P and L correspond with each other?
Yeah.
How did you know that? Because it's kind of flipped and turned and all that, right? Anyone have a kind of an idea, Chris? How can we know that P and L are corresponding angles?
Because you can see that the 55 and the 35 match up with.
Right. So the 55 and those match up, right? And these two match up. So basically all this has just been is translated over. That's a slide, right? And then rotated a little bit up. You guys get that? Maybe like 30 degrees or something like that. Okay, now here's the deal. We don't know what this angle is right here. Can we figure out that angle? Cody, pull me a stick. All right, Tess. How can we figure out that angle right there? There's always 180 degrees in a triangle, right? That is called the triangle angle sum theorem. Did we prove that using parallel lines and alternate interior angles? We proved that. There's always 180 degrees in a triangle. That's a proof. That's called the triangle angle sum theorem. So, Tess, if you take 55 and add 45 and subtract from 180, what do you get? Does everyone agree it's 80?
Yeah.
Okay, now, ladies and gentlemen, how would we figure out the x value that makes this triangle over here congruent? What would we do? Cody, pull a stick.
It's okay. So how we solve the bottom one for P? Yep.
I want to know what the x value is.
Okay. Yeah, the x value should be 10 because 5 times 10 would be 50 plus 30 would be 80, and since they're
That's too hard. Can we just solve the equation? I can't do that kind of math in my head.
I was just
I know, but I like algebra. What's the equation we'd write?
5. I'm sorry.
5x plus 30 has to equal what?
80.
Okay, does everyone understand? For these two triangles to be congruent, their corresponding angles must have the same measure. So in order to do that, we need to set those two equations equal to each other. Now, yes, Tegan is able to do that kind of high-powered math in her head, but Mr. Roden is not, right? Mr. Roden needs help. So what would we do first, Tegan?
Well, you'd want to subtract 30 from 80.
Yep.
Which would be 5x equals 50, yeah. Mm-hmm. And then you want to divide by 55. I'm not dumb, I swear. And then x equals 10. Divide by 50, yeah.
X equals 10? What's 50 divided by 5?
10.
5. Okay. Yeah, got it. Good.
I thought it was wrong.
No.
The way you said that, I was like, oh.
You're right. Yep. Perfect. Okay. Just seeing if you're confident in your answer. All right, guys. Let's do the next one. Here we go. Try this mamba jamba right here. I know.
Why do you guys let it go? Like, just let it go.
Just let it go.
You'll learn eventually.
I'm just copying and pasting another problem in here. Okay, here we go. Copy these down. Okay, go. Copy those down. So the hardest thing for me is to visualize when they've been transformed is to try to visualize the corresponding parts, okay? So if they don't have what we call the same orientation, that you have to look at the corresponding parts, okay? So notice, guys, they did give us all the angles, and they are giving us all the sides, and they're saying these things. They're saying, hey, these two triangles are congruent, so find the x value that's going to make that happen. But look at all the other givens they've given you. They've given you two pairs of congruent sides, and they've given you all three angles. So they have to do that at this point. Okay. All right, Mr. Cody, pull me a stick. All right, Mr. Will, what is the equation we're going to write here to find the value of y that makes these two triangles congruent? Okay, so Will, here's the deal. What side on this triangle right here, thanks, Brady, thank you. What side on this triangle right here, okay, is going to correspond with on the other triangle, Will? What does DF correspond with over here?
BA.
Do you guys agree that those two are corresponding sides? Guys, what would be the transformation that gets you from the left triangle to the right triangle? What do you think, Caitlin? What would be the transformation? What? Okay, if you flip, which one would you flip? If you take this one right here, right? And you're just saying flip it up? Is that what you're saying? Yeah, if you just flip this one up, I think we're in good shape. Okay, Will, so what's the equation we'd write if those are the two corresponding sides?
Is it BA is congruent?
Okay, so Will, hold on. I do agree that BA is congruent to what that would make DE, right? I agree with that, Will. So if you take it to the next step, what can we represent side BA with? What thing?
36.
36. Very good. And we know if they're congruent, they have to be equal measures, right, Will? So what's the measure of DE?
2y plus 20.
Very good. Now, Will, stick with me here. What are we going to do? Let's solve for y. What are we going to do first? We're solving this. Yeah, we're going to take away the 20s, right? We're doing this good old-fashioned algebra. It's good review of algebra, guys. Will, what's 36 minus 20? 16. Equals 2y, right, Will?
Yes.
What's next?
You take away the 2.
How would I do that? What would I do?
Do you divide?
Yes, this is multiplication, so I divide both sides by 2. So y equals what, Will?
Y equals 4.
What's 16 divided by 2, Will?
8.
That's all right. Okay. All right. Y equals 8. You guys see that? Okay. I'm going to freeze it. I'm going to put another problem up here. Give me a second.
Right?
Yeah.
I listen to anyone who tells me answers except that was not the right answer.
No. Do you get?
I wish
Okay.
Famous words from my dad.
Okay, ladies and gentlemen, here we go. Okay, look at this one. I don't know what example is next. I'm just copy and paste this from my. Okay, now, here's what I want you guys to do. Right now, I want you to copy these. I want you to sketch a picture of this. It doesn't have to be on graph paper. You can just sketch a picture. And then what I want you guys to do is I want you to decide whether these two triangles are congruent. Okay? So go ahead and do that. You should actually have enough skills in your geometry tool belt right now to solve this. Okay? So even if you don't have to trace the graph paper. If you want to trace the two, if you just want to kind of put it coordinate plane down, you don't have to do all the graph paper lines. I want you to trace this. And I want to figure out, are these two triangles congruent based upon what we have learned in the past? And we should be able to do this. Do I need to video this a little bit?
Yeah.
Yeah, I'll video it. Yep. In order for two triangles to be congruent at this point in our lives, we must show that 6 parts are congruent to each other. In other words, in this case, it's probably going to be dealing with measures. So we need 3 sides and 3 angles.
Sorry.
We didn't copy.
Oh, so that has to be a great angle. Or isn't that a right angle? Yeah, definitely a right angle.
What does the graph paper, what kind of, putting this on a coordinate plane on graph paper, what does that give us? Why is that important it's on the coordinate plane? Why is that important? We can find sides, right, without having to measure. What else? Can we find angles also? Is there an angle that we could figure out pretty easy in here?
90 degrees.
Yeah, because it's on the coordinate plane, by definition of the coordinate plane, the graph papers all intersect, they're all perpendicular to each other, right? That's the definition of the coordinate plane, that everything's perpendicular to each other. Okay, so let's get through this a little bit. So Cody, I want you to pull me a stick and let's start adding some measures in here because we're missing lots of measures. So Cody, pull me a stick. Okay, not here. Next, Cody. Okay, Dakota, give me one piece of information that you can deduce from this picture right here. An angle, a side, I don't even care.
My brain is broke, but if B and E are congruent, then A is.
Okay, hold on. B and E, what kind of angles are B and E?
They're 90 degrees.
They're 90, so they're right angles. Do we all agree that those two are, okay. Now, ladies and gentlemen, why are those two angles right angles, Dakota? Because it's on the coordinate plane. Very good. So now, what do we have here, guys? If we're talking angles, we've got this angle corresponds with this angle, right, Dakota?
Yes.
Okay. What does angle A correspond with? I'll do a different color here.
It corresponds with angle D.
Okay, so we don't know what angle D is, right? So could we figure out angle D, Dakota?
Yes.
How could we figure out angle D?
Since it's congruent to angle A, then they have the same measure.
But we don't know they're congruent. We have to find this measure, right? We don't know this measure yet. We need this measure. Guys, how can we figure out this angle D right here? Could we figure it out? What could I do to figure it out? But how would I need the measure. I don't know if it's congruent yet. Nicole, what can I do?
You could, since it'll all equal to 180.
Triangle angle sum theorem, right? All triangles add to 180. So if I add 90 plus 26.6 and subtract that from 180, what do I get, Nicole?
You get 63.4.
Do you guys agree that this is 63.4 right here?
Yeah.
So now we can say this. We can say angle B is congruent to angle E because they're right angles on the coordinate plane. We can now say that angle D is congruent to angle A, right, Dakota? Because we use the triangle angle sum theorem. Now, we're still missing an angle here, guys. We don't know if C and F are congruent to each other. I don't know if these two angles are. Maybe they're different. Is there a way to figure out C and F here? Can I find C? I don't know what C is. That's my here. Cody, pull me a stick. I need someone to tell me how I'm going to figure out C. Austin, how am I going to figure out C?
So you'll do 90 plus 63.4 minus 180.
Okay, and what does that give me?
26.6.
That gives me 26.6. So now 26.6. So ladies and gentlemen, we can now say that angle angle C is congruent to angle F. Are we able to say that these two triangles are congruent, guys? No, we're not, because we only have the angle information. In order to prove two triangles are congruent, at this point, we have to talk about the sides. You guys understand that? Okay, so let's talk about AB. How long is the measure of AB, class?
3.
1, 2, 3. What's its corresponding side? How long is that? 3. So now we can say that AB is congruent to DE. Y'all see that? Okay, what's another corresponding side we have to look at? EF. How long is EF? What is it? How long is BC? So we can now say that EF is congruent to BC because they're both 6. Now, but here's the thing. We can't count graph paper lines on diagonal lines, right? So what must we do here, Sophia? The distance formula. So right now, ladies and gentlemen, I'll give you a second. If you've not performed the distance formula, I need you to do that. I need you to perform the distance formula so you can find the measure of AC and the measure of FD. And then I'm going to have Cody pull me a stick, and I am going to expect you to be able to tell me what those lengths are using the distance formula. Cody, give it a second. Okay? So when you get your stick pulled, you've got to tell me what the distance is. Okay? It's a good application of the distance formula. If you did have some misses on that last test because we messed up our distance formula a little bit, right? You're welcome to leave it as a square root if it's not a perfect square. But it should. It's not a perfect, yeah. So we're just going to leave it as a perfect, we're going to just leave it as a square root. Okay, Mr. Cody, pull me a stick. All right, Mr. Brady, you feel comfortable about this?
I think so.
Okay, Brady, when you took the distance formula of AC, what did you get for that?
Square root of 45.
Yeah.
Do you guys agree with that?
It's 4, guys. It's 4.
Square root of 45?
Yeah.
Okay, all right. Brady, when you took the square root of DF, what did you get? So Brady, what can we now say about AC and DF?
AC is congruent to DF.
Why?
Because they both have the same measure. Square root of 45.
All right, here we go. Now, Cody, last stick, grand finale.
Pick your own.
Tanner, what can we now say about these two triangles? So Tanner, sorry. Cody's my stick puller. Tanner, can you please give me a triangle congruent statement now that you know they're congruent? Triangle A, B, C is congruent to, what is it? Triangle DEF. Okay, do we all agree that A corresponds with D, and B corresponds with E, and C corresponds with F? It just happens to be boring alphabetical. Guys, are you guys starting to see this a little bit? Now, before we go anymore, listen up. Okay, now, a couple things. I'm surprised that you guys didn't argue with me kind of like Chris did about the sides. If the angles are all the same size, do you guys still think that holds if they're two?
Yes.
Yeah.
So just take one of these triangles and shrink it down really mini. Do they still have the same angles, just be really too small?
Yeah.
Oh. So I don't think the angles actually is as strong of an argument as the sides, right? So here's what we're going to do. Okay. So here's what we're going to do in the next couple of days. We're going to go through and we're going to start to look at arguments versus make angles. About what if we just know the sides? Do we have to know the angles? Or what if we know maybe a side and another angle or something like that? So what we're going to do is we're going to start to find, these are called triangle congruence rules, okay? And it's because this is a lot of work, and there's going to be some shortcuts involved with this. You guys understand that? And we're going to start out by looking at Chris's rule. Sound good? All right, guys. Hold on. Delta math. I did put a delta math in there. Hold on. Now, let me show you what it looks like. Okay. So, guys, here's a delta math that I want to show you here. Hey, Will, can you take a seat really quick? So, when you go in your delta math, and let me just look at the assignment really quick. I just want to show you kind of what it looks like. Sorry to make you late. I'll get out of here quick. I just posted it. Yep. It's just identifying corresponding angles. Okay. So what? Hold on. It's not just triangles. It's going to be shapes that have been flipped and everything, and you just have to figure out where the corresponding angles are. Sound good? Have a great day. We'll see you later. It's due Monday. Hey, Chris, whose is that right there? Can you pick that up? I don't know whose that is. I think was that Will's. Thank you. Throw it away, Chris. Thanks, man. Thanks, Cody. Good job. Brady, I'll have that grade by the end of the day, all right? You give that here, young lady. Okay. And then, and I will post the...
Can we see the problems that we did wrong now?
Yes, let me do that. I'll do that. Not today.
And when do we need to turn in those, fixing the problem? Friday?
Esme left her.
Yeah, let's make it Friday. What?
I'll take I'll
You want to bring it to
I
her?
have her next year.
All right, cool. Thank you.
They should wreck.
Yeah.
I swear if they lose. They didn't score until the last 5 minutes.
Hold on, Mr. Roden.
Hello, how are you? Good to see you, Gracie.
What are we doing today?
We're going to do some math, Gracie. Does that sound good?
So no notes?
Oh, we're doing notes. You bet we are.
Please tell me it's not a lot.
Yeah, it's going to be kind of heavy notes today, yeah.
Monday I don't bring my notebook.
Where's your notebook, Gracie?
It's at home. I left it in my binder because here's the thing, is that with the whole new tardy system, right? And the way I am in the mornings, I'm like trying to get there on time.
Yeah.
Right? And so I'm trying to find a way to do that, right?
Yeah, that makes sense.
I had the cat box, right? The cat litter, had to clean that out because my mom told me so.
Yeah.
That, and then I can
Nicole has your computer.
and then I can get away with not doing it in the afternoon. And it's like, that's kind of better,
Yeah.
not doing it in the afternoon.